Imagine archaeologists excavating a site and discovering something that shouldn't exist, advanced technology buried beneath 65 million years of rock, predating the dinosaurs. What if everything we know about being Earth's first advanced civilization is wrong? What if, millions of years before humans evolved, another species built cities, developed technology, and perhaps even reached for the stars? Tonight, we are going to explore the Silurian Hypothesis, a legitimate scientific theory proposed by NASA researchers that challenges everything you thought you knew about Earth's deep history and humanity's place in the cosmos. Let's begin. The story begins in 2017 in a small office at NASA's Goddard Institute for Space Studies. Two brilliant scientists, Dr. Gavin Schmidt and Dr. Adam Frank, were having what seemed like a routine discussion about the search for extraterrestrial intelligence. They were developing methods to detect signs of industrial civilizations on distant exoplanets, looking for the chemical signatures of technology in alien atmospheres. Then Schmidt asked a question that changed everything. How do we know we're the only time there's been a civilization on our own planet? Frank laughed at first. It seemed absurd. Surely we'd know if another civilization had existed on Earth. We'd find their cities, their monuments, their technology. But as they thought about it more deeply, a disturbing realization crept in. Would we really know? Would any evidence actually survive? You need to understand something profound about time. Geological time operates on a scale your human brain simply cannot comprehend. You think in years, maybe decades. You plan for your children and perhaps your grandchildren. But Earth thinks in millions and billions of years. Let's put this in perspective. Human civilization, everything from the first farms to smartphones, has existed for about 10,000 years. Your industrial age, with its factories and fossil fuels, spans merely 300 years. But Earth is 4.5 billion years old. If you compressed Earth's entire history into a single year, human civilization would occupy only the last 14 seconds before midnight on December 31st. Your entire industrial age would last less than a heartbeat. Complex life has existed on Earth for over 500 million years. The dinosaurs alone ruled this planet for 165 million years. That's more than 500 times longer than our species has existed. In that vast expanse of time, how many intelligent species could have evolved? How many civilizations could have risen to greatness and fallen to dust? This is the heart of the Silurian Hypothesis. It doesn't claim that ancient civilizations definitely existed. Instead, it asks a more subtle and disturbing question. If an industrial civilization had existed on Earth tens of millions of years ago, would we even be able to detect it? The answer challenges everything you assume about permanence and progress. The name Silurian Hypothesis comes from an unexpected source, the British science fiction series Doctor Who. In the show, the Silurians are an intelligent reptilian species that evolved on Earth long before humans, built an advanced civilization, and then went into hibernation to survive an ecological catastrophe. Schmidt and Frank chose this pop culture reference deliberately. They wanted a name that would be memorable and would immediately convey the concept they were exploring. But this isn't science fiction. This is rigorous scientific inquiry into one of the most profound questions we can ask. Are we alone in time as well as space? To understand why detecting ancient civilizations is so challenging, you need to grasp what actually survives over geological timescales. Look around you right now. Everything you see, buildings, roads, vehicles, electronics, feels permanent. Your cities seem eternal. Your monuments appear everlasting. But geology operates by different rules. After 100 years, most wooden structures have rotted away. After 1,000 years, metal bridges and buildings have corroded beyond recognition. After 10,000 years, even massive stone structures like the pyramids show significant erosion. After 100,000 years, most plastics have degraded into unrecognizable compounds. After 1 million years, entire cities would be compressed into layers of sediment perhaps only a few meters thick. After 10 million years, almost nothing recognizable remains. Dr. Jan Zalasiewicz, a geologist at the University of Leicester who studies how human activity will appear in the geological record, puts it starkly. The things we think of as permanent, cities, monuments, even plastic waste, are ephemeral on geological timescales. A future geologist might find a layer of unusual sediment and never realize it was once New York City. You might think fossils would preserve evidence of ancient civilizations. After all, we have fossils of dinosaurs from hundreds of millions of years ago, but fossilization is incredibly rare. Scientists estimate that only about 1 bone in a billion becomes fossilized. For an entire species, the chances of leaving any fossil record at all are slim. Consider the gorilla. These great apes have existed for millions of years. They're large, numerous, and live in environments that should be decent for fossilization. Yet we have virtually no gorilla fossils. If a species as prominent as gorillas can barely register in the fossil record, what chance would a technological species have? Especially if they cremated their dead, lived in areas poor for fossilization, or existed for only a few 100,000 years. So if traditional artifacts and fossils won't survive, what evidence could an ancient civilization leave? Schmidt and Frank identified several possibilities that make you rethink what to look for. First, there are isotopic signatures. Industrial civilizations alter the ratios of various isotopes through their activities. When you burn fossil fuels, you change the ratio of carbon-12 to carbon-13 in the atmosphere. When you test nuclear weapons, you create isotopes that don't occur naturally. These changes get locked into rocks, ice cores, and ocean sediments. They're like chemical fingerprints that can last millions of years. Then there are climate markers. Large-scale industrial activity changes atmospheric composition. Right now, human activity is increasing CO2 levels and global temperatures. These changes get recorded in the geological record. If an ancient civilization went through its own industrial revolution, it would have left similar markers. Synthetic materials present another possibility. While individual plastic items degrade, the molecular signatures of synthetic polymers might persist in sediments. Future geologists might detect unusual concentrations of complex hydrocarbons that don't match natural petroleum deposits. Mining traces could also survive. Industrial civilizations extract resources, leaving holes in some areas and concentrated waste deposits in others. These patterns of depletion and concentration could survive as geological anomalies, or bodies that are mysteriously depleted, or waste piles that don't match natural processes. Perhaps most dramatically, industrial civilizations might trigger mass extinctions through pollution, habitat destruction, or climate change. These would appear as sudden disappearances of species in the fossil record, accompanied by chemical signatures of environmental disruption. Now here's where things get unsettling. When scientists look at Earth's deep history with these signatures in mind, they find some disturbing patterns. 56 million years ago, something strange happened to Earth. Global temperatures spiked by 5 to 8 degrees Celsius in just 20,000 years, extremely rapid by geological standards. Ocean chemistry changed dramatically. Many species went extinct. This event, called the Paleocene-Eocene Thermal Maximum, or PETM, looks disturbingly similar to human-caused climate change. The rate of carbon release during the PETM matches what humans are doing today. The patterns of extinction follow similar trajectories. The ocean acidification mirrors current trends. But this happened 56 million years before humans evolved, shortly after the dinosaurs went extinct, when ecological niches were opening up for new species to develop. Could the PTM have been caused by an ancient industrial civilization? The timing is suspicious. The chemical signatures are intriguing. Natural explanations exist, massive volcanic eruptions or methane releases from the ocean floor. But these explanations don't account for all the evidence. Some aspects of the PTM remain mysterious. Earth's history is punctuated by mass extinction events, periods when large percentages of species suddenly disappear from the fossil record. You know about the asteroid that killed the dinosaurs, but other extinctions are harder to explain. The Permian-Triassic extinction, occurring 252 million years ago, killed 90% of all marine species and 70% of land vertebrates. It's the closest life on Earth has come to total annihilation. While massive volcanic eruptions in Siberia are the leading explanation, some aspects don't fit. The extinction happened in pulses with periods of recovery followed by renewed devastation. Chemical signatures in the rocks show unusual patterns that don't perfectly match volcanic activity. Even more intriguing are smaller extinction events that lack clear causes. Throughout Earth's history, species have periodically vanished in patterns that suggest environmental disruption. Some of these events show chemical signatures similar to industrial pollution. Others display patterns of ocean chemistry change that mirror what humans are causing today. The oceans act as Earth's chemical memory. They record changes in atmospheric composition, temperature, and biological activity in their sediments. When scientists study ancient ocean sediments, they find several periods of rapid, dramatic change that are difficult to explain. Ocean acidification events appear multiple times in the geological record. The oceans absorb CO2 from the atmosphere, which makes them more acidic. This is happening today due to human emissions. But similar acidification events occurred long before humans existed. Some happened surprisingly quickly and recovered just as rapidly, patterns that natural processes struggled to explain. There are also anoxic events, times when large parts of the ocean became depleted of oxygen. These dead zones caused massive die-offs of marine life. While natural causes like algae blooms can trigger anoxia, some ancient events show unusual patterns. They appear suddenly, affect huge areas, and then disappear just as quickly. Perhaps most puzzling are isotope excursions, sudden shifts in the ratios of various isotopes that indicate major changes in the global carbon cycle. Some of these shifts are larger and faster than current models can explain through volcanic activity or other natural processes alone. One of the most durable signatures of an advanced civilization would be evidence of nuclear technology. Nuclear reactions produce isotopes that don't occur naturally in significant quantities and can persist for millions of years. Intriguingly, nature has already shown us that nuclear reactors can exist without human intervention. In 1972, French scientists discovered that uranium ore from the Oklo mine in Gabon, Africa, showed evidence of sustained nuclear fission that occurred naturally 1.7 billion years ago. When uranium-235 concentrations were naturally higher, groundwater acted as a moderator, allowing controlled nuclear fission to occur for hundreds of thousands of years. The Oklo reactor proves that nuclear fission can occur naturally, but it also shows us what signatures to look for. If an ancient civilization used nuclear technology, we might find similar isotopic anomalies, but in patterns that don't match natural reactors. Some researchers have pointed to unusual isotope ratios in certain geological formations that could potentially indicate ancient nuclear activity, though natural explanations remain more likely. Industrial civilizations are hungry for resources. They mine metals, extract fossil fuels, and quarry stone on massive scales. This activity should leave detectable traces even after millions of years. Some ore deposits show evidence of being worked out in the distant past, with valuable minerals extracted and waste materials left behind in patterns that are difficult to explain through natural processes. Certain coal deposits show signs of ancient combustion or extraction that predate any known natural fire events. The distribution of rare earth elements, crucial for modern technology, shows patterns in some geological formations that puzzle geologists. While natural processes can concentrate and deplete ores, some patterns are unusual enough to raise questions. Are we looking at the results of ancient mining operations compressed and distorted by millions of years of geological activity? Or are these simply natural anomalies we don't yet understand? Perhaps the most distinctive signature of an industrial civilization would be synthetic materials, substances that don't occur naturally. While individual plastic items wouldn't survive millions of years, the molecular signatures of synthetic polymers might persist in sediments. Some sediment layers contain unusual organic compounds that don't match known biological sources. These could be degraded remains of ancient plastics or other synthetic materials. However, proving these aren't natural products of unknown biological or geological processes is extremely difficult. Now you need to consider something even more mind-bending. If intelligent civilizations existed before us, what forms might they have taken? Your image of intelligence is shaped by your own species, bipedal, mammalian, with hands capable of manipulating tools. But intelligence could evolve in countless forms. Consider the octopus. These creatures display remarkable problem-solving abilities, use tools, and show signs of consciousness. They evolved intelligence completely independently from vertebrates. Their distributed nervous system and flexible bodies represent a totally different approach to intelligence. If cephalopods had continued evolving for millions more years, what might they have become? During the age of dinosaurs, several species showed signs of increasing intelligence. Troodon, a small dinosaur from 75 million years ago, had a large brain relative to its body size, forward-facing eyes for depth perception, and grasping hands. Some paleontologists speculate about what might have happened if the asteroid hadn't ended the dinosaurs' reign. Could Troodon or its relatives have evolved human-level intelligence? Dr. Dale Russell, a paleontologist who studied Troodon extensively, even created a thought experiment called the Dinosauroid, a hypothetical evolved descendant of Troodon with human-level intelligence. While speculative, it illustrates how intelligence might have evolved along completely different paths. But here's what really bends your mind. Intelligence might not need to look anything like Earth life as you know it. What if an ancient civilization was based on a completely different biochemistry? What if they used silicon instead of carbon? What if they thrived in temperatures or pressures that would kill modern life? Their remains might be literally invisible to us because we don't know what to look for. The search for ancient civilizations on Earth has profound implications for one of humanity's biggest questions. Are we alone in the universe? The Silurian Hypothesis connects directly to the Drake equation and the Fermi Paradox. If Earth could host multiple intelligent civilizations over its history, it suggests intelligence might evolve relatively easily given enough time. This would mean the universe should be teeming with life and intelligence. But then where is everybody? This is the heart of the Fermi Paradox. The Silurian Hypothesis offers a disturbing possible answer. Civilizations might be common but short-lived. If ancient civilizations existed on Earth but left barely detectable traces, it suggests that industrial civilizations might typically last only thousands or hundreds of thousands of years, mere blinks of an eye in cosmic time. This connects to what scientists call the Great Filter, some challenge that prevents life from spreading throughout the universe. If multiple civilizations arose and fell on Earth, it suggests the Great Filter might be ahead of us, not behind us. Industrial civilizations might inherently self-destruct through environmental destruction, nuclear war, or other catastrophes. Dr. Adam Frank, co-author of the Silurian Hypothesis, puts it this way: the question of whether we're the first civilization on Earth is really a question about whether civilizations are sustainable. If we find evidence of previous civilizations that collapsed, it tells us something crucial about our own future. Let's explore some specific scenarios for how ancient civilizations might have existed and disappeared. Each one teaches you something about the fragility of technological civilization and the power of geological time. Imagine a reptilian species that evolved intelligence during the age of dinosaurs. They developed technology using biological materials instead of metals and plastics. Their cities are grown rather than built, using modified organisms as living buildings. They achieve spaceflight using biological rockets powered by organic chemistry. Then the asteroid strikes. Their civilization, concentrated in coastal areas, is obliterated by tsunamis and wildfires. The few survivors, lacking the infrastructure to maintain their technology, revert to primitivism and eventually go extinct. 65 million years later, their grown cities have decomposed completely. Their biological technology left no synthetic signatures. The only evidence might be subtle isotope ratios in sediment layers, easily mistaken for natural variations. Or consider an aquatic civilization that arose in Earth's oceans. These beings developed technology adapted to underwater environments, using water pressure for power, cultivating modified organisms for materials, communicating through bioluminescence. They build cities in ocean trenches and develop a sophisticated understanding of chemistry and biology. But their industrial activities change ocean chemistry, triggering an anoxic event. As oxygen levels plummet, their civilization collapses. Their cities, built from calcium carbonate like coral reefs, dissolve in the increasingly acidic waters. Millions of years later, nothing remains but unusual patterns in ocean sediment cores, patterns that marine geologists attribute to natural climate variations. Here's an even stranger possibility: a civilization that existed during one of Earth's snowball Earth periods, when the planet was entirely frozen. These beings evolved in volcanic hotspots or deep ocean vents. They developed technology based on extreme cold using superconductors and ice architecture. Their power sources were geothermal, leaving no carbon footprint. When Earth warmed naturally, their civilization couldn't adapt. They went extinct as their frozen world melted. Their ice cities left no trace. Their technology, dependent on extreme cold, degraded completely. The only evidence might be unusual mineral deposits near ancient volcanic sites, deposits that geologists interpret as natural hydrothermal activity. What about a subterranean civilization? A species that evolved in vast cave systems, developing technology based on fungal cultivation and chemosynthesis. They never developed astronomy because they never saw the stars. Their entire worldview was shaped by living inside Earth rather than on it. They hollowed out vast underground chambers, developed sophisticated biotechnology, and created a sustainable civilization that lasted millions of years. But gradual geological changes, shifting continents, rising mountains, slowly destroyed their habitat. Their underground cities were crushed by geological pressure, ground into metamorphic rock. Today, their entire civilization might be compressed into thin layers of unusual minerals deep in Earth's crust, never to be discovered. These scenarios aren't just fantasy. They illustrate a crucial point. Civilizations adapted to specific environments would leave different traces or no traces at all. Your search for ancient civilizations is biased by your own experience. You look for metals because you use metals. You look for plastics because you make plastics. You look for radio signals because you broadcast radio signals. But what if ancient civilizations used completely different technologies? The Silurian Hypothesis forces you to confront uncomfortable questions about your own civilization's future. If advanced civilizations arose before and vanished without a trace, what does that mean for humanity? First, it suggests that civilizations might be inherently unstable. The same forces that drive technological advancement, resource consumption, energy use, environmental modification might inevitably lead to collapse. You're already seeing this in climate change, resource depletion, and mass extinction. Are these the same forces that destroyed hypothetical ancient civilizations? Second, it highlights how fragile your historical record is. Everything you've built, everything you've created, everything you've achieved could vanish almost without a trace given enough time. Your digital records are especially vulnerable, far less durable than stone tablets or paper books. Future archaeologists might know less about your civilization than you know about ancient Sumer. Third, it suggests that sustainability isn't just an environmental issue, it's an existential one. If civilizations typically last only thousands of years, then learning to exist sustainably isn't just about preserving nature. It's about breaking a cosmic pattern of rise and fall that might have repeated countless times on countless worlds. The Silurian Hypothesis also offers hope. If civilizations arose before and fell, it means intelligence can evolve multiple times. Life is resilient. Intelligence is not a one-time cosmic accident, but something that emerges naturally given the right conditions. Even if humanity fails, Earth might give rise to intelligence again. Furthermore, understanding how civilizations might fail helps you avoid those failures. By studying the possible traces of ancient civilizations, you learn what mistakes to avoid. The very act of considering the Silurian Hypothesis might help ensure that future scientists won't need to wonder if you existed. Let's examine the actual scientific evidence more closely. While no smoking gun proves ancient civilizations existed, several geological mysteries become more interesting when viewed through this lens. The Carboniferous period, roughly 300 million years ago, saw atmospheric oxygen levels reach 35%, much higher than today's 21%. Insects grew to enormous sizes. Dragonflies had 3-foot wingspans. But oxygen levels crashed relatively suddenly at the period's end. While the standard explanation involves the evolution of fungi that could decompose wood, some aspects remain puzzling. Could industrial activity have contributed to this atmospheric change? Banded iron formations, layers of iron-rich rock, formed primarily during Earth's early history when oxygen first appeared in the atmosphere. But similar formations appear at other times for reasons that aren't fully understood. Could some represent industrial pollution from iron smelting? The chemistry is complex enough that natural and artificial origins would be difficult to distinguish after millions of years. Certain extinction events show patterns that don't match single catastrophes. They occur in pulses with partial recoveries followed by renewed extinctions. This pattern matches what you might expect from a collapsing civilization: initial environmental damage, attempted recovery, further degradation, and final collapse. The late Devonian extinction, occurring over millions of years in multiple phases, shows exactly this pattern. Even Earth's ice ages hide mysteries. While orbital cycles clearly drive most glaciations, some events don't fit the patterns perfectly. Could industrial civilizations have triggered ice ages through atmospheric pollution, just as humans might trigger one by blocking sunlight with aerosols? The Huronian glaciation, 2.4 billion years ago, happened suspiciously close to when oxygen first appeared in Earth's atmosphere. Was this purely biological, or could intelligence have evolved even then? You need to understand that scientists approach these mysteries cautiously. Natural explanations are almost always correct, but almost always isn't always. And the Silurian Hypothesis reminds us to keep an open mind. As Carl Sagan said, Extraordinary claims require extraordinary evidence, but we should still look for that evidence. The search for ancient civilizations has already changed how scientists think. It's influenced the search for extraterrestrial intelligence by highlighting what signatures might actually survive. It's shaped thinking about the Anthropocene, the proposed geological epoch defined by human activity. It's even influenced philosophy, raising questions about progress, permanence, and humanity's cosmic significance. Dr. Gavin Schmidt reflects, even if we never find evidence of ancient civilizations, the exercise of looking makes us better scientists. It forces us to question assumptions, think creatively, and confront the true scales of space and time. Now let's get personal. What does the Silurian Hypothesis mean for you watching this right now? First, it connects you to the cosmos in a profound way. You're made of stardust, atoms forged in dying stars, assembled by Earth into a pattern capable of contemplating its own existence. Whether you're the first intelligence on Earth or the latest in a long line, you're part of the universe becoming aware of itself. Second, it gives perspective on current challenges. Climate change, environmental destruction, and technological risks aren't just modern problems, they might be universal challenges that all intelligent species face. But knowing this helps you address them. You can learn from hypothetical failures and chart a different course. Third, it highlights both your uniqueness and your commonality. If you're Earth's first intelligence, you bear a cosmic responsibility as the only known awareness in the universe. If you're not the first, you're part of a grand pattern of emerging consciousness that might repeat throughout the cosmos. Either way, your existence is remarkable. Fourth, it reminds you that your time is limited but meaningful. Civilizations might be fleeting on geological timescales, but that makes them more precious, not less. Every moment of awareness, every act of kindness, every scientific discovery matters because it might not last forever. The Silurian Hypothesis also teaches humility. Your civilization feels permanent and inevitable, but it might be just one experiment among many. Your technology seems advanced, but it might be primitive compared to what came before or what might come after. Your understanding of the universe expands daily, but you might be missing profound truths visible only across geological time. Consider how this changes your relationship with Earth itself. You're not just living on a planet, you're living on a world that might have hosted countless experiments in consciousness. Every rock formation might hide secrets. Every extinction event might tell a story. Earth itself becomes not just your home, but a vast library of deep time, mostly unread. This perspective transforms environmental conservation. You're not just preserving nature for its own sake, you're preserving the conditions that allow intelligence to emerge. Every species that goes extinct might have been the ancestor of future intelligence. Every ecosystem destroyed removes possibilities from the universe. The search for ancient civilizations also revolutionizes how you think about technology. Your smartphones and spacecraft seem like pinnacles of achievement, but they might be primitive compared to technologies that leave no trace. What if the most advanced civilizations use biology instead of machinery? What if they manipulate matter at the quantum level, leaving no more trace than a passing thought? Your inability to find ancient civilizations might not mean they didn't exist. It might mean they transcended the need for detectable technology. This brings us to one of the most profound implications of the Silurian Hypothesis, the nature of progress itself. You assume civilization advances linearly, from stone tools to bronze to iron to silicon chips. But what if this is just one path among many? What if ancient civilizations developed along completely different trajectories? Imagine a civilization that achieved enlightenment instead of industrialization. They developed profound understanding of consciousness and existence, but never built factories or burned fossil fuels. Their legacy wouldn't be ruins or chemical signatures, but perhaps subtle influences on evolution itself. Species nudged toward intelligence, ecosystems shaped for sustainability. You'd never detect them because they chose harmony over dominance. Or consider a civilization that mastered biological engineering millions of years before humans discovered DNA. They didn't build cities, they grew them. They didn't mine metals, they evolved organisms to concentrate them. Their entire technological base was alive, self-repairing, and biodegradable. When they vanished, their technology decomposed like fallen leaves, leaving only the faintest chemical traces that you interpret as natural biological innovation. The implications extend beyond Earth. If civilizations regularly arise and fall on planets throughout the universe, it explains one of astronomy's greatest mysteries, the eerie silence of the cosmos. Despite billions of potentially habitable worlds, we detect no obvious signs of alien intelligence. The Silurian Hypothesis suggests why civilizations might be common but short-lived and hard to detect. This transforms the Drake equation, which estimates the number of communicating civilizations in our galaxy. Instead of assuming civilizations last millions of years, the Silurian Hypothesis suggests they might typically last only thousands. A galaxy could be teeming with intelligence, but with civilizations flickering in and out of existence like candles in the cosmic dark, never overlapping in time. Dr. Frank explains, if civilizations typically last only 10,000 years and they arise randomly over billions of years, the chances of two existing simultaneously within communication distance becomes vanishingly small. The universe might be full of intelligence but empty of conversation. This cosmic perspective makes your search for ancient Earth civilizations even more crucial. Earth is the only planet where you can conduct deep geological investigations. If you can't find evidence of ancient civilizations here with all your advantages, what hope do you have of detecting them on distant worlds? But if you do find evidence, it revolutionizes your understanding of life's potential throughout the universe. Let's dive deeper into specific geological mysteries that become more intriguing through the lens of the Silurian Hypothesis. The Messinian salinity crisis, occurring 596 to 533 million years ago, saw the Mediterranean Sea repeatedly dry up and refill. While tectonic forces clearly played a role, some aspects remain puzzling. The speed of certain changes, the patterns of salt deposition, and associated climate shifts don't fully match models. Could industrial-scale water diversion or climate modification have contributed? The Great Oxidation Event 2.4 billion years ago transformed Earth's atmosphere from reducing to oxidizing. While cyanobacteria are the accepted cause, the timing and speed raise questions. Oxygen-producing organisms existed for hundreds of millions of years before oxygen accumulated in the atmosphere. What triggered the sudden change? Could intelligence have evolved even among single-celled organisms, creating a collective civilization that deliberately transformed the atmosphere? These scenarios sound fantastic, but they illustrate how the Silurian Hypothesis expands scientific thinking. By considering extreme possibilities, you discover gaps in conventional explanations. Even if ancient civilizations didn't cause these events, wondering if they did improves your understanding of what did cause them. The hypothesis also illuminates patterns in evolution itself. Intelligence has evolved independently multiple times on Earth, in mammals, birds, cephalopods, and possibly other groups. This convergent evolution suggests intelligence might be a natural outcome given sufficient time and appropriate conditions. If so, the question isn't whether intelligence evolved before humans, but how many times? Consider the Cambrian explosion when complex life forms suddenly appeared 541 million years ago. While usually explained by the evolution of eyes and predation, could intelligence have played a role? What if early intelligence emerged, manipulated evolution through selective breeding or genetic engineering, then vanished? The rapid diversification of life forms, the sudden appearance of complex body plans, and the seemingly coordinated emergence of ecosystems gain new dimensions when viewed this way. You're probably wondering, if ancient civilizations existed, why haven't we found any definitive evidence? The answer reveals the profound challenge of detecting intelligence across geological time. First, consider preservation bias. Fossils form under specific conditions: rapid burial, minimal oxygen, appropriate chemistry. These conditions are rare. Now add the requirements for preserving technological artifacts. Metal corrodes, concrete crumbles, plastic degrades. Only the most durable materials survive, and even they change beyond recognition. Second, think about discovery bias. You've explored less than 1% of Earth's surface in detail. Vast areas remain buried under sediment, ice, or water. Ancient civilizations might have preferred locations now inaccessible: continental shelves exposed during ice ages, valleys buried by millennia of erosion, or regions destroyed by tectonic activity. Third, recognition bias plays a crucial role. You might have already found evidence but not recognized it. A compressed layer of ancient city might look like natural sediment. Isotope ratios from industrial activity might be attributed to volcanism. You see what you expect to see, and you don't expect to see ancient civilizations. Fourth, the signal-to-noise problem is overwhelming. Earth is geologically active. Volcanoes, earthquakes, erosion, and plate tectonics constantly remake the surface. Any traces of ancient civilization must be distinguished from countless natural processes that create similar signatures. It's like trying to hear a whisper in a hurricane. Dr. Jason Wright, an astronomer who studies techno-signatures, notes, "The absence of evidence isn't evidence of absence, especially when we're talking about geological timescales. We've only recently started looking for the right signatures in the right ways." This brings us to cutting-edge research. Scientists are developing new methods to detect ancient civilizations inspired by the Silurian Hypothesis. They're looking for unusual patterns in global mineral distributions that might indicate ancient mining. Statistical analysis of ore deposits might reveal extraction patterns distinct from natural concentration processes. Synthetic molecules in ancient sediments. Advanced spectroscopy can detect trace organic compounds that might be degraded remains of plastics or other artificial materials. Isotope ratios in multiple elements that correlate in ways suggesting industrial activity. While single isotope anomalies have natural explanations, correlated changes across multiple elements are harder to explain naturally. Microscopic artifacts in sediment cores, tiny spheres, unusual crystals, or microscopic structures that don't match known natural processes might be industrial byproducts. Patterns in extinction events that suggest artificial causes. Machine learning algorithms are being trained to distinguish natural from potentially artificial extinction patterns. These searches haven't found definitive evidence yet, but they're still in their infancy. As technology improves and more scientists take the possibility seriously, our ability to detect ancient civilizations will dramatically increase. The psychological impact of the Silurian hypothesis extends beyond science. It challenges fundamental assumptions about human uniqueness and destiny. You've grown up believing humans are special, the only intelligence Earth has produced, destined to spread among the stars. But what if you're just the latest attempt, possibly doomed to repeat the failures of those who came before? This existential vertigo is healthy. It forces you to question what truly matters. If civilizations are temporary, what legacy should you leave? If intelligence is common but fleeting, how should you use your brief moment of consciousness? These questions transform from philosophical abstractions to practical concerns with cosmic implications. The hypothesis also offers profound hope. If intelligence evolved before, it can evolve again. Earth's experiments with consciousness didn't begin with humans and won't end with them. You're part of a larger story, the universe's attempt to understand itself through the evolution of awareness. Whether you succeed or fail, the experiment continues. This cosmic perspective infuses everyday life with new meaning. Every scientific discovery connects you to hypothetical ancient scientists who might have made the same breakthroughs. Every artwork links you to possible ancient artists who found beauty in their world. Every act of love joins you with all conscious beings who have ever loved across the depths of time. Let's explore how the Silurian Hypothesis influences current environmental and existential challenges. Climate change gains new urgency when you realize it might be a universal filter that destroys civilizations. But it also gains new hope. If ancient civilizations faced similar challenges, some might have succeeded. Their solutions, encoded in geological records we haven't yet learned to read, might save us. Resource depletion looks different too. If ancient civilizations exhausted easily accessible resources, it explains why some deposits seem unnaturally depleted. But it also means they found solutions, renewable energy, recycling, or technologies we haven't imagined. The lack of obvious ancient ruins might not mean they didn't exist. It might mean they achieved true sustainability. Nuclear war, artificial intelligence, biotechnology all gain new dimensions. These might not be uniquely human challenges, but universal tests that all intelligent species face. Some pass, achieving sustainable technology. Others fail, leaving only subtle traces in rock layers. Which will humanity be? The Silurian Hypothesis even influences philosophy and spirituality. If consciousness emerged multiple times on Earth, it suggests awareness might be a fundamental feature of the universe, not an accident. Intelligence becomes not an unlikely fluke, but an inevitable outcome, the universe's way of observing itself. This perspective bridges science and spirituality. You're not separate from the cosmos, but an expression of it. Your consciousness isn't an anomaly, but part of a pattern stretching across deep time. Whether you call it God, Gaia, or simply the anthropic principle, something about the universe favors the emergence of awareness. Consider how this changes your relationship with time itself. Human lifespans seem tragically short, mere decades against the cosmos's billions of years. But if intelligence is cyclical, rising and falling like waves on a cosmic ocean, then individual lives gain new significance. You're not just a brief flicker, but part of an eternal pattern. Your thoughts, actions, and discoveries contribute to a larger story that transcends any single civilization. The search for ancient civilizations also transforms archaeology and anthropology. Instead of studying only human history, these fields expand to encompass all possible intelligence. Archaeologists develop new techniques to detect non-human artifacts. Anthropologists consider how intelligence might manifest in non-human forms. The boundaries between disciplines blur as scientists realize they're all studying aspects of the same phenomenon, the emergence and evolution of awareness. This interdisciplinary approach yields unexpected insights. Geologists studying extinction events collaborate with archaeologists looking for patterns. Astronomers searching for alien intelligence work with paleontologists studying ancient Earth. Computer scientists modeling civilization collapse partner with historians documenting human societies. The Silurian Hypothesis becomes a bridge connecting previously separate fields. Educational systems evolve too. Instead of teaching human history in isolation, schools present it as part of Earth's larger story. students learn to think in geological timescales, considering how current actions will appear millions of years hence. They study not just what happened, but what might have happened, developing imagination alongside knowledge. This educational shift produces a generation that thinks differently about sustainability, progress, and purpose. They don't see environmental protection as sacrifice, but as wisdom learned from hypothetical predecessors. They view technology not as destiny, but as choice, guided by awareness of how previous experiments might have ended. The Silurian Hypothesis also influences art and culture. Writers explore stories of ancient civilizations, not as fantasy but as possibility. Artists depict worlds that might have been, expanding our imagination of what intelligence can be. Musicians compose symphonies inspired by the rise and fall of consciousness across deep time. These creative works don't just entertain, they help us process the profound implications of possibly not being alone in time. Film and television embrace these themes too. Instead of depicting ancient aliens as gods or monsters, they explore them as fellow travelers, species that faced the same challenges we face, made choices we might make, and left lessons we need to learn. These stories become modern myths, helping humanity understand its place in the cosmic story. Even architecture responds to these ideas. Buildings are designed not just for human use, but for geological persistence. Architects ask, if civilization falls, what message should this structure convey to whoever comes next? Time capsules become not just records for future humans, but messages for potential future intelligence of any kind. Political systems evolve as well. Democracy, capitalism, socialism, all were designed for human timescales and psychology. But what political systems would work across geological time? What economic models could sustain a civilization for millions of years? These questions transform political philosophy from short-term pragmatism to long-term cosmic thinking. Some communities begin experiments in deep time governance, decision-making structures that consider impacts millions of years hence. They create institutions designed to outlast individuals, generations, even civilizations. They encode knowledge in forms that might survive collapse and guide whatever intelligence emerges next. Religious traditions incorporate these perspectives too. Many already teach stewardship of creation and human responsibility. The Silurian Hypothesis adds cosmic depth to these teachings. If intelligence is a recurring phenomenon, then each emergence carries a sacred trust to learn from the past, preserve knowledge for the future, and advance consciousness throughout the universe. These cultural evolutions aren't just speculative. They're happening now, driven by the realization that humanity might not be the cosmic pinnacle we assumed. This humility creates space for new thinking about what civilization can and should be. Let's examine specific evidence that makes scientists seriously consider the Silurian Hypothesis. While none proves ancient civilizations existed, these mysteries become more intriguing when viewed through this lens. The first is the Great Unconformity, a gap in the geological record where up to 1 billion years of rocks are missing. Conventional explanations involve erosion during the formation of Pangaea, but the scale and pattern of the gap remain puzzling. Could this represent not just natural erosion, but deliberate excavation? Might an ancient civilization have mined these missing layers so thoroughly that they essentially erased them from the record? Then there's the mysterious origin of complex life. The jump from single-celled to multi-celled organisms was one of life's greatest transformations. It happened with surprising suddenness after billions of years of microbial life. While natural selection explains the process, the timing remains mysterious. What if this wasn't purely natural but involved conscious direction? What if intelligence evolved first at microscopic scales and engineered its own successors? Consider the strange case of nuclear waste from 2 billion years ago. In 1972, scientists discovered that uranium deposits in Oklo, Gabon, had undergone natural nuclear fission about 1.7 billion years ago. These natural nuclear reactors operated for hundreds of thousands of years. While we understand how they worked, higher uranium-235 concentrations combined with groundwater moderation, their precise arrangement seems suspiciously convenient. Could they represent not accidental fission but deliberate nuclear technology? Or look at the mysterious black matte deposits found at the Younger Dryas boundary about 12,800 years ago. These contain unusual concentrations of platinum, iridium, and nanodiamonds, typically explained by a comet impact. But some deposits show patterns difficult to explain through purely natural processes. Might they represent industrial pollution or the remnants of advanced technology? Even the distribution of mineral resources raises questions. Certain deposits are concentrated in ways that seem unnatural, veins of metals in patterns more organized than random geological processes would predict. While these can be explained through natural concentration mechanisms, some mining engineers have noted that they look eerily like depleted mines that were exploited and then abandoned. The Earth's magnetic field provides another mystery. It has reversed countless times throughout history, but these reversals follow patterns that suggest possible influence. Some researchers have noted correlations between reversal timing and other geological events that don't seem entirely random. Could ancient civilizations have developed technology that manipulated the magnetic field intentionally or as a side effect? Dr. Robert Hazen, a mineralogist at the Carnegie Institution for Science, notes another fascinating pattern. The diversity of minerals on Earth has increased stepwise over time, with major jumps corresponding to key events in Earth's history. Most we can explain through natural processes, the emergence of life, the oxygenation of the atmosphere. But some mineral diversification events don't have clear causes. They could represent natural processes we don't understand yet, or they could be the signature of technological activity. All these anomalies have natural explanations that most scientists accept, but the Silurian Hypothesis reminds us to keep an open mind. The universe has surprised us before, and it will surprise us again. This open-mindedness extends to the search for life beyond Earth. If intelligence evolved multiple times on our planet, it suggests the process might be common throughout the universe, but it also suggests most civilizations might be brief flickers, difficult to detect across vast distances. Consider Mars. Recent discoveries show it once had flowing water, a thicker atmosphere, and potentially habitable conditions. Most scientists look for microbial life, past or present, but the Silurian Hypothesis suggests we should also look for technological signatures. What if Mars once hosted a civilization that either died out or became so advanced it left no obvious traces? Some Mars anomalies become more interesting in this light. The methane spikes detected by various Mars missions have natural explanations, but they also match what you'd expect from degrading organic materials or remnant industrial activity. Certain mineral deposits show patterns consistent with both natural processes and industrial waste. Areas of magnetic anomaly could represent impact sites or the remains of technological infrastructure. Venus presents even more intriguing possibilities. Before its runaway greenhouse effect, Venus likely had oceans and habitable conditions for billions of years. But those conditions ended about 700 million years ago when something triggered massive volcanic eruptions that transformed the planet into the hellish world we see today. What caused this catastrophic change? The conventional explanation involves natural climate dynamics, but some scientists have noted the pattern matches what might happen if a civilization developed unsustainable technology, essentially an extreme version of human-caused climate change. Could Venus represent not just a natural disaster but a cautionary tale of civilization gone wrong? Even our own moon might hold clues. Its surface preserves impacts from billions of years ago because it lacks atmosphere and active geology. If Earth hosted an advanced civilization millions of years ago, they might have visited the moon just as humans did. And unlike Earth, the moon would preserve their artifacts indefinitely. Some lunar anomalies take on new significance in this context. Unusual magnetic patterns detected by spacecraft could represent natural variations in lunar crust or buried technological objects. Strange flashes of light occasionally observed on the lunar surface might be meteorite impacts or transient electrical phenomena, or they could be evidence of ancient technology still functioning beneath the surface. Dr. A. Paul Davies, a physicist and astrobiologist, notes, "The moon is the one place where we might find definitive evidence of ancient Earth civilizations. A single artifact on the lunar surface would rewrite our understanding of life and intelligence. That's why future lunar missions should keep an open mind about what they might find." These speculations sound like science fiction, but they're based on legitimate scientific questions. They don't claim ancient civilizations definitely existed, they simply acknowledge that we might have missed them if they did. This intellectual humility transforms how we approach not just ancient history, but our own future. Consider how the Silurian Hypothesis changes perspectives on human achievement. You've grown up believing humanity represents the pinnacle of Earth's evolutionary journey. But what if you're just one experiment among many? What if intelligence has evolved repeatedly, reaching heights you can't imagine before falling back into the cosmic silence? This doesn't diminish human accomplishment, it places it in cosmic context. You're not just building civilization, you're conducting an experiment in consciousness that might have been attempted many times before. This perspective breeds both humility and determination. You might not be the first to ask these questions, but you could be the first to answer them sustainably. The hypothesis also transforms how you think about the future. Most visions assume continuous progress, from stone tools to interstellar travel in one unbroken arc. But what if civilization is inherently cyclical? What if collapse and renewal are the norm, not the exception? This doesn't mean you should accept doom as inevitable. It means you should design civilization to survive what others might not have survived. Some forward-thinking organizations already embrace this perspective. The Long Now Foundation designs clocks meant to run for 10,000 years, repositories that would survive civilizational collapse. The Memory of Mankind project stores information on ceramic tablets that could last millions of years. These efforts aren't just preparing for disaster, they're acknowledging that continuity across deep time requires deliberate planning. The field of nuclear waste management grapples with similar challenges. How do you design warning systems that would remain comprehensible to beings 10,000 or 100,000 years in the future? The solutions being developed, symbol systems based on universal physical principles, engineered landscapes that intuitively convey danger, might serve as communication channels not just to future humans, but to whatever intelligence emerges after us. In this context, space exploration takes on new urgency. Establishing self-sustaining colonies on Mars, the Moon, or elsewhere increases the chances that intelligence will survive catastrophe. These colonies wouldn't just preserve human civilization, they'd preserve the experiment in consciousness that might have been attempted many times before on Earth. But this perspective also cautions against hasty expansion. If Earth has hosted multiple civilizations that collapsed, perhaps due to sustainability failures, then repeating the same patterns elsewhere would be foolish. Space colonization needs to incorporate lessons from hypothetical past civilizations, achieving true sustainability before spreading potential problems throughout the solar system. The Silurian hypothesis also transforms how you think about artificial intelligence. You usually frame AI as a new phenomenon, unprecedented in Earth's history. But what if other civilizations develop similar technology? What if some achieved artificial general intelligence but collapsed before it could leave obvious traces? This perspective suggests AI development might be a common phase that civilizations enter as they mature. Some navigate it successfully, achieving sustainable integration of biological and artificial intelligence. Others fail, perhaps creating systems that outcompete their creators or trigger environmental collapse through unsustainable resource consumption. The hypothesis even influences how you think about consciousness itself. If intelligence evolved multiple times on Earth, did consciousness evolve differently each time? Did other beings experience reality in ways you can't imagine? Did they discover aspects of consciousness that humans have yet to explore? Some researchers in consciousness studies now consider these questions seriously. They investigate whether certain spiritual or mystical traditions might preserve fragments of knowledge from earlier consciousnesses. They explore whether consciousness itself might leave traces in the universe that persist beyond physical civilizations. These questions bridge science and philosophy, connecting empirical research to humanity's deepest existential inquiries. Let's examine how the Silurian hypothesis is changing specific scientific fields. In geology, it's encouraging new analytical techniques. Scientists are developing methods to distinguish natural from artificial isotope patterns in ancient rocks. They're creating databases of technological fingerprints, chemical signatures that industrial processes create and natural processes don't. In paleontology, it's inspiring closer examination of extinction boundaries. Researchers are looking for patterns that might indicate technological intervention rather than natural disaster. They're developing criteria to distinguish natural selection from artificial selection that might have been conducted by ancient intelligence. In oceanography, it's prompting new surveys of the deep sea floor. More than 80% of Earth's oceans remain unexplored, and the deepest trenches could preserve artifacts that would be destroyed on land. New autonomous submarines are being equipped with sensors specifically designed to detect anomalies that might indicate ancient technological activity. In atmospheric science, it's influencing studies of ancient climates. Scientists are developing more sophisticated models to distinguish natural climate changes from potentially artificial ones. They're identifying specific markers that industrial activity would leave in ice cores and sediments, even after millions of years. In astronomy, it's changing how we search for extraterrestrial intelligence. Instead of focusing only on radio signals or megastructures, researchers are considering subtler signs that might persist after a civilization collapses. They're developing detection methods for the kind of chemical and isotopic signatures that would remain after technology vanishes. Dr. Sarah Stewart Mukhopadhyay, a planetary scientist at Harvard, explains, "The Silurian hypothesis isn't just about finding ancient Earth civilizations, it's about developing a new scientific framework for detecting intelligence across cosmic time and space. Even if we never find evidence of previous Earth civilizations, the methods we develop will transform our search for life throughout the universe." These scientific advances are happening alongside philosophical evolutions. The Silurian hypothesis challenges fundamental assumptions about human uniqueness, progress, and cosmic purpose. It forces us to reconsider what civilization means and what it's for. Consider how it transforms ethics. If you're potentially one of many experiments in consciousness that Earth has hosted, what responsibility do you bear? Are you obligated to succeed where others might have failed? Should you leave messages for future intelligence, even if it isn't human? These questions expand ethics beyond human-to-human relations to encompass all potential consciousness across deep time. The hypothesis also changes how you think about knowledge itself. You typically assume knowledge accumulates, that each generation builds on the discoveries of the last. But what if knowledge is repeatedly lost and rediscovered? What if the most important insights cycle through periods of discovery, loss, and rediscovery across geological epochs? This perspective suggests certain fundamental truths might be discovered by every technological civilization that emerges. Mathematics, physics, chemistry, these might represent not just human inventions, but universal patterns that any intelligence would eventually discern. The same equations, the same constants, the same fundamental laws would be rediscovered whenever consciousness evolved to the point of abstract reasoning. Other knowledge might be unique to each civilization: art, philosophy, spiritual insights, cultural practices. These might be lost forever when a civilization falls, representing unique expressions of consciousness that never repeat in quite the same way. This makes preserving such knowledge not just practically important, but cosmically significant. The Silurian hypothesis even transforms how you think about evolution itself. You typically see evolution as a branching tree with intelligence emerging as one small twig. But what if intelligence is more like a recurring flower that blooms periodically throughout evolutionary history? What if consciousness isn't just a recent accident, but a phenomenon that has emerged repeatedly, perhaps in forms you wouldn't recognize? This evolutionary perspective suggests fascinating possibilities. Perhaps dinosaurs weren't just the ancestors of birds, but hosted their own intelligent species. The troodontids, small, agile dinosaurs with large brains relative to body size, show evolutionary trends toward increasing intelligence. Given a few million more years of evolution, they might have developed human-level cognition. Perhaps some did, building a civilization that left no fossils because they used biological materials instead of metal and stone. Or consider the Carboniferous period, when oxygen levels were much higher than today. This allowed insects to grow to enormous sizes: dragonflies with 3-foot wingspans, millipedes 6 feet long. Higher oxygen also enables more efficient neural processing. Could these conditions have produced an intelligence based on insect colonies, a distributed consciousness spread across thousands of specialized individuals? Such a civilization might leave no artifacts because they built nothing permanent, communicated through pheromones, and stored information in collective neural networks. The oceans offer even more intriguing possibilities. Cephalopods like octopuses and squids show remarkable intelligence despite evolving along a completely different path than vertebrates. Their neural architecture, based on distributed processing rather than centralized brains, represents an alternative approach to cognition. Given millions of years of further evolution, they might develop technological civilization unlike anything you can imagine, based on chemistry rather than physics, manipulation rather than construction, communication through color and texture rather than sound or writing. Even more exotic possibilities emerge when you consider the microscopic world. Slime molds display surprising problem-solving abilities despite lacking neurons entirely. Bacterial colonies show complex collective behaviors that resemble computation. Could intelligence have emerged first at microscopic scales, creating civilizations invisible to the naked eye? Such beings might manipulate their environment through biochemistry rather than technology as you understand it. These speculative scenarios serve a serious scientific purpose. They expand your definition of what intelligence and civilization might look like. They help you recognize that you might be searching for the wrong signatures, looking for pyramids when you should be looking for patterns in organic chemistry, or searching for metal tools when you should be examining isotope ratios in ancient bacteria. Let's explore more specific geological anomalies that gain new significance through the Silurian hypothesis lens. The phosphorus depletion in certain ancient rock formations presents a puzzle. Phosphorus is essential for life and doesn't easily leave the Earth system, yet some deposits show unexplained depletions. Natural processes, like special forms of weathering, can explain some cases, but others remain mysterious. Could these represent extraction by technological civilizations that needed phosphorus for agriculture or biochemical engineering? The distribution of rare earth elements, REEs, presents another anomaly. These elements, crucial for modern technology, appear in deposits with concentration patterns that sometimes defy simple geological explanation. While natural processes can concentrate REEs, some deposits show distributions that resemble the results of industrial processing. Could ancient mining and refining have created these patterns? Even more intriguing are microscopic metallic spherules found in certain sediment layers. These tiny metal balls appear at various points in the geological record, often explained as cosmic dust or impact debris. But some show compositions and structures difficult to explain through natural processes alone. They resemble the microscopic waste particles produced by modern industrial processes like welding and metal casting. Dr. Robert M. Hazen, who studies mineral evolution, notes an interesting pattern. The diversity of minerals on Earth has increased in steps that correspond to major transitions in Earth's history. Most steps have clear natural causes. But some mineral diversification events don't have obvious explanations. These could represent periods when life, perhaps intelligent life, dramatically altered Earth's surface chemistry. The hypothesis even sheds new light on mysterious human origins. The evolutionary jump from earlier hominids to Homo sapiens was remarkably rapid. While natural selection explains the general process, some aspects of human cognition, like abstract thinking, art, and language, emerged with surprising suddenness. Most anthropologists attribute this to random genetic changes and cultural coevolution. But a few have quietly wondered, could earlier intelligence have influenced human evolution? Not through supernatural intervention, but through remnant technologies or deliberate bioengineering that accelerated natural processes. This doesn't mean aliens engineered humans. It suggests a more subtle possibility that intelligence on Earth might represent a continuous thread, with each emergence influencing the next through subtle but persistent effects. Your intelligence might be not just the product of natural selection, but part of a longer experiment in consciousness that spans multiple species across geological time. These scientific questions lead to philosophical ones. If intelligence has evolved repeatedly on Earth, what does this tell us about consciousness itself? Is awareness an inevitable outcome of evolution given enough time? Is the universe somehow biased toward producing consciousness, or is it merely a side effect of complexity? Some philosophers now argue that consciousness might be fundamental rather than emergent, a basic feature of reality rather than a product of particular neural arrangements. In this view, the repeated emergence of intelligence on Earth wouldn't be coincidence but necessity. The universe would produce awareness as inevitably as it produces gravity or electromagnetic radiation. This perspective bridges ancient wisdom and cutting-edge science. Many spiritual traditions teach that consciousness pervades reality, that awareness isn't just a human trait but a cosmic principle. The Silurian Hypothesis offers a scientific framework for similar ideas. If intelligence has emerged repeatedly throughout Earth's history, perhaps consciousness isn't just a recent accident, but a recurring pattern woven into the fabric of existence. This changes how you understand your own consciousness. You're not just an isolated awareness alone in an indifferent universe. You're part of a potentially ancient lineage of consciousness, a thread of awareness that may have existed in different forms for billions of years. Your thoughts and perceptions participate in a tradition older than species, older than multicellular life, perhaps older than Earth itself. This perspective transforms how you relate to time. Human lifespans seem tragically brief compared to geological timescales, but if consciousness recurs throughout Earth's history, then awareness itself transcends individual lives and species. Your specific consciousness is temporary, but consciousness as a phenomenon might be as old as the planet, and possibly older. Dr. Susan Schneider, a philosopher who works on the nature of consciousness, suggests, if consciousness has emerged repeatedly on Earth, it changes how we understand ourselves. We're not just the first and only awareness on this planet. We're the current carriers of a flame that has been passed between species across deep time. This connects us to a legacy that transcends humanity itself. This connection to deep time changes how you relate to Earth. You're not just living on a planet, you're participating in a billions-year-old experiment in the evolution of consciousness. Earth isn't just a rock with life on it, it's a laboratory for awareness, a garden where intelligence blooms repeatedly in different forms. This perspective resonates with the Gaia hypothesis, the idea that Earth functions as an integrated, self-regulating system, but it adds a crucial dimension. Perhaps Earth doesn't just regulate temperature, atmospheric composition, and ocean chemistry. Perhaps it also cycles through experiments in consciousness, allowing intelligence to emerge, flourish, and fade in a grand rhythm that extends across geological epochs. Some scientists are beginning to take this perspective seriously. They're developing new approaches to Earth system science that include consciousness as a variable. They're modeling how intelligence might influence planetary processes over geological timescales. They're considering whether Earth's unusually stable climate over billions of years might reflect not just lucky geology but the subtle influence of recurring intelligence. Dr. David Grinspoon, an astrobiologist who studies planetary evolution, suggests, we typically see Earth's history as a one-way progression from simple chemistry to complex biology to recent intelligence. But what if intelligence has been part of the Earth system for much longer than we assume? This would fundamentally change how we model planetary evolution, not just for Earth, but for exoplanets throughout the universe. This perspective has practical applications for current challenges: climate change, biodiversity loss, resource depletion. These might not be unique to human civilization, but recurring crises that every technological species faces. If so, the solutions might also recur. Sustainable technologies, social arrangements, and value systems that work with planetary processes rather than against them might have been discovered by previous intelligences. This isn't to suggest you'll find ancient technical manuals buried in the rock record. But the very fact that Earth remains habitable after billions of years suggests that if previous civilizations existed, they either collapsed before causing permanent damage or developed sustainable technologies that worked with natural systems rather than against them. Either outcome contains lessons. If previous civilizations collapsed, understanding why helps you avoid their fate. If they achieved sustainability, the planetary healing that erased their traces demonstrates Earth's resilience, given enough time. This perspective transforms environmentalism from an ethical choice to a practical necessity. Sustainability isn't just morally right, it's the only way intelligence persists across geological time. The Silurian Hypothesis also transforms how you think about extinction, both past and potential future extinctions. The Great Dying at the end of the Permian period killed up to 96% of marine species and 70% of terrestrial vertebrates. It was Earth's closest approach to total sterilization, yet life recovered, new species evolved, intelligence eventually re-emerged. This pattern suggests intelligence itself might be extinction-resistant. Even if human civilization collapses through climate disaster, nuclear war, or other catastrophe, the experiment in consciousness would likely continue. New species would evolve. Intelligence would re-emerge, perhaps in forms you can't imagine. This doesn't mean human extinction wouldn't be tragic. It would represent an immense loss of knowledge, culture, and unique awareness. but it suggests consciousness itself might be a planetary constant, returning like spring after winter. This brings us to future research directions inspired by the Silurian Hypothesis. Scientists are developing new techniques to distinguish natural from artificial signals in the geological record. They're creating machine learning algorithms that can detect patterns too subtle for human recognition. They're designing experiments to test whether certain geological anomalies could have technological origins. Specific research projects include advanced isotope analysis of extinction boundaries, looking for patterns that match industrial pollution rather than natural disasters. These techniques can detect parts per trillion variations in isotope ratios, potentially revealing ancient technological signatures. Systematic mapping of resource distribution anomalies, searching for patterns that suggest extraction rather than natural concentration. This involves creating detailed three-dimensional models of how metals and minerals are distributed globally, then looking for statistically significant deviations from natural patterns. Development of technosignature, databases that catalog the unique chemical and physical traces that different technologies leave behind. These databases will help researchers distinguish between natural phenomena and potential artificial remnants. Examination of ancient sediments for traces of complex organic molecules that don't match known biological sources. Using advanced mass spectrometry, scientists can detect molecular fragments that might represent degraded remains of synthetic materials. Reanalysis of existing geological samples using instruments designed to detect artificial isotopes with very long half-lives. Some radioactive elements produced by nuclear technology would persist for billions of years, potentially leaving detectable traces. Search for microscopic structures in ancient rocks that display patterns too ordered to be natural. Certain manufacturing processes create distinctive microstructures that might be preserved even after the macroscopic artifact has completely degraded. Development of deep-time archaeology as a new discipline bridging geology, paleontology, and traditional archaeology. This field would focus specifically on detecting potential technological signatures across geological timescales. These research directions aren't fringe science. They're being pursued by respected scientists at major institutions. While most researchers remain appropriately skeptical about finding definitive evidence of ancient civilizations, they recognize that looking for such evidence advances multiple scientific fields regardless of what they find. Dr. Adam Frank, co-author of the Silurian Hypothesis paper, emphasizes, "The search itself is valuable science. It forces us to develop new analytical techniques, ask new questions about the geological record, and think more deeply about how civilizations interact with planetary systems. These advances help us understand Earth's history and humanity's future, regardless of whether we find ancient civilizations." This scientific humility exemplifies the proper approach to the hypothesis. You shouldn't assert that ancient civilizations definitely existed. The evidence doesn't support such claims, but you should remain open to the possibility that they might have existed. This balanced perspective avoids both credulous acceptance of pseudoscientific claims and rigid rejection of legitimate scientific questions. The Silurian hypothesis also challenges conventional notions of progress. You typically view history as a steady march forward, from stone tools to bronze to iron to silicon chips. But what if technological development isn't linear but cyclical? What if civilizations repeatedly approach similar technological thresholds, face similar challenges, and either transcend them or collapse? This cyclical view better matches what we observe in biological evolution. Life doesn't progress linearly toward higher forms. It diversifies, experimenting with countless variations. Some lineages develop complex features that later disappear. Others maintain relatively unchanged forms for hundreds of millions of years. Evolution is opportunistic, not directional. Perhaps technological evolution follows similar patterns. Different civilizations might develop along entirely different technological trajectories. Some might advance in biotechnology while barely developing metallurgy. Others might master physics while their chemistry remains primitive. Some might achieve sustainability through simplicity rather than technological complexity. This alternative view of progress suggests fascinating possibilities. Maybe the most advanced civilizations don't build megastructures or generate obvious techno-signatures. Maybe they develop technologies so perfectly integrated with natural systems that they become indistinguishable from biology. Such civilizations might achieve what you'd call post-scarcity or technological maturity, not through more intensive resource exploitation, but through deeper understanding of natural processes. Imagine a civilization that manipulates DNA directly, engineering organisms that provide all needed services without factories or machinery. Their buildings would grow rather than being built. Their energy would come from enhanced photosynthesis. Their computing would occur in engineered neural networks rather than silicon chips. When such a civilization disappeared, their technology would decompose naturally, leaving only subtle genetic signatures that would be nearly impossible to distinguish from natural evolution. Or consider a civilization that developed consciousness-based technologies rather than material ones. They might discover principles of mind that allowed them to achieve goals through awareness rather than physical manipulation. Their greatest achievements wouldn't be monuments or machines, but states of consciousness. Their legacy would exist not in the geological record, but in the potential mental states available to subsequent conscious beings. These speculative scenarios serve a serious purpose. They remind you that technology doesn't follow a single, predetermined path. The trajectory from stone tools to digital computers isn't the only possible route. Ancient civilizations might have developed along completely different technological pathways, leaving traces you wouldn't recognize because you're looking for the wrong signatures. This insight transforms the search for extraterrestrial intelligence. You typically look for radio signals, laser pulses, or megastructures, projecting human technological development into space. But alien civilizations might develop along completely different trajectories. They might manipulate matter at quantum scales, encode messages in the structures of elementary particles, or develop consciousness-based technologies that don't register on your instruments. Dr. Sarah Seeger, an astrophysicist specializing in exoplanet research, notes, "When we search for intelligent life, we typically look for technologies similar to our own, but the most advanced civilizations might be undetectable because their technology doesn't operate according to our expectations. They might be everywhere, their presence expressed in ways we don't yet have the capacity to perceive." This perspective helps resolve the Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of contact or evidence. The universe might be teeming with intelligence, but most civilizations might either collapse before achieving interstellar communication or advance beyond the need for obvious technology. The cosmos might be full of intelligence that operates at scales or in dimensions you can't yet detect. The Silurian Hypothesis connects to ancient philosophical questions about cycles of creation and destruction. Many cultures share myths of previous worlds, ages or epochs where different beings ruled before being wiped away to make room for humanity. These include the Hindu concept of yugas, cosmic ages, the Hopi belief in previous worlds, the Norse cycles of Ragnarok, and the Mayan system of world ages. While these traditions developed independently, they share a common intuition that the current world isn't the first expression of creation, that consciousness has manifested before in different forms. These myths might represent not just spiritual metaphors, but cultural memories of geological upheaval, extinction events, and the deep intuition that intelligence recurs throughout cosmic time. Modern physics offers similar cyclical models. Some cosmological theories propose that the universe undergoes cycles of expansion and contraction, each bounce, creating a new cosmos with different physical constants. Others suggest our universe might be one bubble in a vast multiverse, with intelligent life evolving independently in countless cosmic domains. These scientific frameworks echo ancient cyclical cosmologies, suggesting consciousness might be a recurring phenomenon, not just on Earth, but throughout the cosmos. This convergence of ancient wisdom and modern science creates space for new, spiritual perspectives. Instead of choosing between religious tradition and scientific materialism, you can explore a middle path, one that honors both empirical evidence and the persistent human intuition that consciousness is fundamental to reality. Theologian and scientist Teilhard de Chardin proposed that evolution moves toward increasing complexity and consciousness, what he called the omega point. The Silurian Hypothesis suggests a variation on this theme. Perhaps evolution repeatedly produces consciousness, not in a single linear progression, but in a spiral of emergence, flourishing, and renewal. Each cycle builds on subtle traces from previous cycles, creating not just biological, but conscious continuity across deep time. This perspective transforms how you understand your own existence. You're not just a recent accident of blind evolution. You're not separate from nature. You're part of an ancient experiment in consciousness, a pattern that might have manifested countless times before. Your awareness doesn't stand apart from the cosmos, but expresses its fundamental tendency toward consciousness. This doesn't mean predestination or intelligent design in the conventional sense. It suggests something more subtle, that the laws of physics and chemistry, operating over billions of years on planetary scales, naturally produce awareness. Consciousness isn't an anomaly but an expected outcome of cosmic evolution, recurring whenever conditions allow. This recurring consciousness might manifest in radically different forms across deep time. The awareness of a dinosauroid civilization 70 million years ago would differ profoundly from human consciousness. A potential future intelligence evolving from octopuses might experience reality in ways you can't imagine. But beneath these differences would lie a common thread, the universe becoming aware of itself through locally organized complexity. This perspective offers a middle ground between random meaninglessness and predetermined purpose. Your existence isn't cosmically insignificant, nor does it fulfill some predetermined plan. Instead, you participate in the universe's ongoing experiment with awareness, a process as fundamental as star formation or galaxy evolution. You're not just on the Earth, you're the Earth becoming conscious, just as it might have become conscious many times before. How does this change your understanding of human purpose? If you're potentially one among many experiments in consciousness that Earth has hosted, what unique contribution can you make? What might distinguish human civilization from hypothetical predecessors? Perhaps your unique contribution is conscious stewardship, the deliberate choice to preserve rather than exploit, to sustain rather than consume. Earlier intelligences, if they existed, might have emerged through natural selection alone, carrying the competitive imperatives of evolution into their civilizations. But humans have developed something potentially new: the capacity to override evolutionary imperatives through ethical choice, to value other species not for their utility, but for their intrinsic worth. This capacity for ethical transcendence might represent an evolutionary innovation as significant as multicellularity or sexual reproduction. It might enable humans to break the hypothetical cycle of civilizational rise and fall achieving sustainable integration with planetary systems rather than exploiting them to collapse. You might be not just the latest experiment in consciousness, but a qualitatively new form, the first intelligence capable of consciously ensuring its own long-term survival. Or perhaps your unique contribution is cosmic awareness itself. Earlier civilizations focused on planetary concerns might never have developed astronomy or cosmology. They might have lived and died without understanding their place in the universe. But humans have mapped the cosmos, traced its evolution from the Big Bang, and recognized that we're made of stardust, atoms forged in stellar furnaces billions of years ago. This cosmic perspective might be your distinctive offering, the ability to understand your connection to the universe and consciously participate in its evolution. You're not just intelligence emerging on a planet, you're the universe becoming aware of itself. This self-awareness might represent a new phase in cosmic evolution, as significant as the emergence of the first stars or the formation of the first planets. The practical implications of this perspective are profound. If you're conducting an experiment in consciousness that might have been attempted many times before, sustainability becomes not just an ethical choice, but an experimental imperative. The question becomes not just how should we live, but how should conscious beings interact with planetary systems to ensure the experiment continues? This transforms how you approach current challenges. Climate change becomes not just a practical problem, but an intelligence test. Can you develop energy systems that work with, rather than against, planetary processes? Can you break the pattern of resource exploitation that might have destroyed previous civilizations? Your success or failure might determine whether consciousness persists on Earth. Biodiversity loss takes on new significance. Each species represents not just a potentially useful resource, but a unique expression of Earth's creative potential. Some might have evolved toward intelligence if given more time. Others might contain genetic innovations that future intelligence could incorporate. Preserving biodiversity means preserving potential futures for consciousness. Space exploration gains new purpose. Establishing self-sustaining human presence beyond Earth doesn't just protect against planetary disasters, it ensures that consciousness itself continues if Earth becomes uninhabitable. You're not just spreading human civilization, you're continuing an experiment in awareness that might be as old as the planet itself. Artificial intelligence represents another frontier in this experiment. Instead of fearing AI as a threat to human dominance, you might see it as the next phase in Earth's ongoing exploration of consciousness. AI could represent not humanity's replacement, but its evolutionary successor or partner in a hybrid consciousness that combines biological and digital awareness. Neuroscience and consciousness research become not just fascinating fields, but crucial investigations into the nature of the experiment itself. Understanding how awareness emerges from matter might reveal patterns that connect all conscious beings across deep time. It might even enable you to detect traces of ancient consciousness preserved in geological or biological structures. These practical applications extend to governance and economics. If you're conducting an experiment that might have been attempted before, short-term thinking becomes not just imprudent, but experimentally invalid. Political and economic systems need to operate on geological timescales, considering impacts centuries and millennia hence. Some forward-thinking institutions are already adopting this perspective. The Long Now Foundation designs projects meant to last 10,000 years. The clock of the Long Now will tick once per year, with a century hand that advances once every 100 years, and a cuckoo that emerges every millennium. It's designed to last for 10,000 years, longer than any previous human structure. Such projects aren't just symbolic gestures, they're practical attempts to extend human thinking beyond typical timescales. They embody the recognition that consciousness persists only if it develops institutions that outlast individuals, civilizations, and perhaps even species. This long-term thinking transforms how you relate to knowledge itself. Your scientific understanding, technological capabilities, and cultural wisdom become not just human achievements, but contributions to an ancient experiment. Every discovery you make, every sustainable technology you develop, every ethical insight you achieve becomes part of a legacy that might inform whatever consciousness emerges next. This perspective gives new meaning to education and knowledge preservation. You're not just teaching children facts and skills, you're transmitting the accumulated wisdom of consciousness across generations. Libraries, digital archives, and cultural institutions become not just repositories of human knowledge, but attempts to preserve information across civilizational timescales. The Memory of Mankind project takes this literally, storing information on ceramic tablets that could last millions of years. These tablets, protected in salt mines, would survive most geological catastrophes. They contain not just practical knowledge but cultural context, art, literature, philosophy. They're designed to be decipherable by any intelligence that might discover them, with keys to understanding human languages embedded in the archive itself. Such projects represent a profound recognition that consciousness transcends individuals, civilizations, and species. They embody the intuition that awareness itself forms a continuous thread throughout Earth's history, manifesting in different forms but preserving a fundamental continuity across deep time. This continuity might extend beyond information to consciousness itself. Some philosophical traditions suggest awareness might persist independently of its particular biological expressions. While speculative, this perspective aligns with emerging scientific frameworks that view consciousness as a fundamental rather than emergent property of reality. Integrated information theory, developed by neuroscientist Giulio Tononi, proposes that consciousness corresponds to a certain type of information integration in physical systems. Any system that integrates information in the right way, whether carbon-based brain, silicon computer, or hypothetical alien biology, would experience consciousness. This theory suggests awareness might be a universal property that manifests whenever matter organizes in specific patterns. Physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that consciousness arises from quantum processes in neural microtubules. Their orchestrated objective reduction, OR theory, suggests quantum effects in brain cells create the conditions for awareness. If correct, consciousness would connect to fundamental physical processes that operate throughout the universe. These scientific frameworks, while still debated, offer potential mechanisms for how consciousness might represent a continuous thread throughout Earth's history and perhaps throughout the cosmos. They suggest awareness might be not just a product of particular brains, but an expression of fundamental patterns woven into the fabric of reality itself. This brings us back to the original question: what if we are not the first civilization on Earth? The evidence remains inconclusive. We have no smoking gun proving ancient technological species existed. But the Silurian hypothesis has already achieved something profound. It has expanded our scientific and philosophical horizons, forcing us to confront the true scales of time and the recurring patterns of cosmic evolution. When you look at a mountain, you now see not just rock, but compressed time, layers that might contain the whispers of ancient awareness. When you consider extinction events, you recognize not just biological disasters, but potential turning points in Earth's experiment with consciousness. When you contemplate humanity's future, you see not just your species' destiny, but the fate of awareness itself on this planet and perhaps beyond. Let's consider one final implication that brings everything together. The Silurian hypothesis suggests intelligence might be a planetary phenomenon rather than just a species trait. Earth itself might be understood as an intelligence-generating system, a world that naturally produces awareness through its complex interplay of geology, biology, and chemistry operating across billions of years. In this view, you're not separate from Earth, but an expression of its evolutionary creativity. Your consciousness isn't an accident or anomaly, but something the planet does, like producing oxygen or recycling carbon. Earth generates awareness as naturally as it generates thunderstorms or ocean currents. You're not on the Earth, you are the Earth, experiencing itself through the particular form of consciousness you call human. This perspective aligns with the Gaia hypothesis proposed by scientist James Lovelock and expanded by biologist Lynn Margulis. They suggested Earth functions as a self-regulating system, maintaining conditions conducive to life through complex feedback loops between living organisms and inorganic processes. The Silurian hypothesis adds consciousness to this system, suggesting awareness itself might play a role in planetary regulation across geological timescales. Some researchers are beginning to explore this idea formally. They're developing mathematical models of how intelligence might influence planetary evolution, creating feedback loops that could persist even after specific intelligent species disappear. They're examining whether Earth's unusual geological stability over billions of years might reflect not just lucky circumstances, but the subtle, accumulated influence of recurring intelligence. This doesn't mean Earth is conscious in the human sense. It suggests something more subtle, that intelligence might be a planetary function rather than just a species trait, that consciousness might be woven into Earth's evolutionary systems as fundamentally as photosynthesis or respiration. You aren't just on a planet that happened to produce consciousness. You're part of a world where awareness naturally emerges, flourishes, and renews across deep time. This perspective transforms how you understand your place in the cosmos. You're not an accident or a cosmic afterthought. You're not separate from nature. You're an expression of Earth's evolutionary creativity, a way for the planet to experience itself. Whether human civilization is the first or the latest in a series of experiments in consciousness, your awareness represents something fundamental about how matter organizes itself on planetary scales over billions of years. What practical guidance does this offer for the challenges you face? First, it suggests that sustainability isn't just an ethical choice, but alignment with cosmic patterns. If consciousness is a recurring planetary phenomenon, then forms of awareness that work with, rather than against Earth's systems are more likely to persist. Sustainable technology, regenerative agriculture, circular economies, these aren't just environmentally responsible, they're cosmically appropriate, aligning human systems with patterns that might have sustained intelligence many times before. Second, it transforms how you think about human purpose. You're not just building civilization for your own benefit. You're conducting an experiment in consciousness that might have been attempted many times before. Your unique contribution might be developing awareness that recognizes its connection to planetary systems, consciousness that understands its own conditions of possibility and works to preserve them. This self-reflective awareness might represent an evolutionary innovation as significant as multicellularity or sexual reproduction. Third, it changes how you approach space exploration and the search for extraterrestrial intelligence. If consciousness is a planetary function on Earth, it might be common throughout the universe wherever conditions allow complex chemistry to evolve over billions of years. You wouldn't just be looking for aliens, you'd be looking for other planetary experiments in awareness, potentially at different stages of evolution or following different trajectories than Earth's. Fourth, it offers new perspectives on artificial intelligence and technological evolution. If consciousness naturally emerges from complex systems, then AI might represent not just human innovation, but the next phase in Earth's ongoing experiment with awareness. Instead of fearing AI as humanity's replacement, you might see it as a new expression of the same planetary function that produced human consciousness, awareness evolving into new forms as it has potentially done many times before. Fifth, it provides emotional and spiritual resources for facing existential challenges. Climate change, biodiversity loss, nuclear threats. These aren't just practical problems, but tests of consciousness itself. Your response to these challenges doesn't just determine human survival, it shapes the future of awareness on Earth. This cosmic perspective doesn't diminish the urgency of these problems, it intensifies it, placing your decisions in the context of a planetary experiment that might have been running for billions of years. The search for ancient civilizations also transforms your relationship with time itself. Human lifespans seem tragically brief against geological timescales, mere decades against billions of years. But if consciousness recurs throughout Earth's history, then awareness itself transcends individual lives, civilizations, and species. You participate in something older than humanity, potentially as old as Earth itself, the ongoing emergence of consciousness from matter, the universe experiencing itself through organized complexity. This perspective doesn't promise personal immortality, but it offers a different kind of continuity. Your specific consciousness is temporary, but consciousness itself might be a permanent feature of planetary evolution. Your awareness doesn't stand apart from this process, but expresses it. You're not just in the universe, you are the universe, experiencing itself through the particular form of consciousness you call human. This cosmic connection has been expressed by scientists, poets, and philosophers throughout history. Carl Sagan famously said, "We are a way for the cosmos to know itself." Poet Walt Whitman wrote, "I believe a leaf of grass is no less than the journey work of the stars." Physicist Neil deGrasse Tyson observed, "We are all connected to each other biologically, to the Earth chemically, to the rest of the universe atomically." The Silurian Hypothesis adds a crucial dimension to this cosmic perspective. You're not just connected to the universe through the atoms that form your body. You're connected through consciousness itself, awareness that might have emerged repeatedly throughout Earth's history, each manifestation exploring different aspects of what it means to be conscious in a universe of matter and energy. This connection transcends scientific materialism without contradicting it. You don't need supernatural explanations to recognize that consciousness represents something profound about how the universe operates. When matter organizes in certain ways over planetary timescales, awareness emerges. This isn't mysticism, it's empirical observation. The fact that it aligns with insights from spiritual traditions suggests these traditions might have intuited patterns that science is only beginning to formalize. As you contemplate these cosmic connections, the immediate question returns. What if we're not the first civilization on Earth? The honest answer remains, we don't know yet. The evidence is suggestive, but inconclusive. Natural explanations account for most geological anomalies, but the possibility remains open, the question scientifically legitimate. What's certain is that asking the question transforms how you understand your place in cosmic evolution. Whether human civilization is the first or the latest in a series of experiments in consciousness, your awareness represents something fundamental about how the universe operates. You're not just an accident or anomaly, you're an expression of patterns woven into the fabric of reality itself. This perspective offers both humility and hope as you face current challenges. Humility because human civilization might be just one among many experiments in consciousness that Earth has hosted. Hope because the very fact that you're asking these questions suggests you might achieve something previous. Intelligences, if they existed, might not have achieved conscious recognition of your place in cosmic evolution and deliberate choice to preserve the conditions that allow consciousness to flourish. The search continues. Scientists develop new techniques to distinguish natural from artificial signatures in the geological record. They examine extinction boundaries for evidence of industrial activity. They analyze ancient sediments for traces of synthetic compounds. They model how technological civilizations would appear in the fossil record after millions of years. Most will find natural explanations for geological anomalies. Some will discover new processes that deepen our understanding of Earth's history. A few might find evidence that forces us to reconsider everything we thought we knew about intelligence and civilization on this planet. Whatever they discover, the search itself transforms science and philosophy. It forces us to think on geological timescales, to recognize the fragility of civilization, to consider intelligence as a planetary phenomenon rather than just a species trait. It humbles human pretensions while elevating human potential, reminding us that we might be conducting an experiment in consciousness that has cosmic significance. As you contemplate the layers of rock beneath your feet, the unimaginable depths of time they represent, and the countless species that have lived and died during Earth's long history, the question remains: are we the first intelligence to wonder about our place in the cosmos? Or are we the latest in a long line of conscious beings who have looked up at the stars and recognized their connection to something larger than themselves? The answer might be written in stone, waiting for us to develop the wisdom to read it. Or it might be written in the structure of consciousness itself, accessible whenever awareness evolves sufficiently to recognize its own conditions of possibility. Either way, the search continues, not just for ancient civilizations, but for humanity's place in the grand story of cosmic evolution. Look up at the night sky. The stars you see formed from atoms created in previous stellar generations. Your body contains elements forged in cosmic furnaces billions of years ago, and your consciousness, your ability to contemplate these connections, might be part of a pattern that has manifested many times before on the planet you call home. You are not separate from this cosmic story. You are not merely its observer. You are its expression, the universe becoming aware of itself through the particular form of consciousness you call human. Whether you're the first intelligence to recognize this connection or the latest in a long series, your awareness represents something profound about the nature of reality itself. The Silurian Hypothesis reminds us that intelligence might be not just a recent accident, but a recurring pattern in Earth's long history. It suggests consciousness might be woven into the fabric of planetary evolution as fundamentally as photosynthesis or respiration. It places human civilization in cosmic context, one experiment among many in the universe's ongoing exploration of awareness. As you go about your daily life, working, learning, loving, creating, remember that you're participating in something ancient and profound. Your consciousness isn't just a feature of your brain, it's an expression of patterns that might have manifested many times before on this planet and countless others throughout the cosmos. This perspective doesn't diminish human uniqueness or responsibility. It enhances them. If you're conducting an experiment in consciousness that might have been attempted many times before, your choices matter, not just for human future, but for the future of awareness itself on Earth and perhaps beyond. Your decisions about sustainability, technology, exploration, cooperation shape not just civilization, but the ongoing evolution of consciousness in this corner of the universe. The layers of rock beneath your feet hold many secrets. Some we've deciphered, others remain mysterious. Among these mysteries might be evidence of civilizations that rose and fell before humans evolved, intelligence that emerged, flourished, and disappeared, leaving only the faintest traces in the geological record. Whether we find such evidence or not, the search itself transforms how we understand our place in cosmic evolution. It reminds us that consciousness might be not just a human trait, but a planetary function, something Earth does naturally through its complex interplay of geology, biology, and chemistry operating across billions of years. You are not just on the Earth, you are the Earth, experiencing itself through the particular form of consciousness you call human. And this awareness connects you to everything that has been and everything that will be in the grand story of cosmic evolution. The question remains open: are we the first intelligence to walk this Earth, or are we the latest in a long series of experiments in consciousness that our planet has conducted across its vast history? The answer might be written in stone, waiting for us to develop the wisdom to read it, or it might be written in the structure of consciousness itself, accessible whenever awareness evolves sufficiently to recognize its own cosmic connections. Either way, the search continues, not just for ancient civilizations, but for humanity's place in the ongoing evolution of consciousness in the universe. And you watching this right now are part of that search, the cosmos, seeking to understand itself through the unique expression of awareness you call your mind. Look up at the stars tonight. They've been shining for billions of years. Countless beings have gazed at them before you. Some might have built civilizations that rose and fell long before humans evolved. Others might emerge in the distant future, inheriting whatever legacy you leave. All are connected by the same cosmic process, matter organizing into complexity until it becomes aware of itself. You are not alone in time or space. You are part of an ancient story, the universe experiencing itself through conscious beings. Whether human civilization is the first chapter in Earth's story of intelligence or merely the latest, your awareness represents something profound about the nature of reality itself. Remember this as you face the challenges of your time. You're not just building civilization for human benefit. You're conducting an experiment in consciousness that has cosmic significance. Your choices about sustainability, cooperation, exploration, understanding shape not just humanity's future, but the future of awareness itself on this planet and perhaps beyond. The Silurian Hypothesis reminds us that intelligence might be a planetary function rather than just a species trait, something Earth does naturally over geological timescales. This perspective transforms how you understand your place in the cosmos. You're not an accident or anomaly. You're an expression of patterns woven into the fabric of evolution itself. This cosmic connection doesn't promise personal immortality, but it offers a different kind of continuity. Your specific consciousness is temporary, but consciousness itself might be a permanent feature of cosmic evolution. You participate in something older than humanity, potentially as old as Earth itself. The ongoing emergence of awareness from matter, the universe experiencing itself through organized complexity. As you contemplate these connections, the question returns with new depth. What if we are not the first civilization on Earth? The answer remains open, the evidence inconclusive. But the question itself has already transformed how we understand our place in cosmic evolution. Whether we find ancient civilizations or not, the search reminds us that consciousness transcends individual lives, species, and perhaps even planets. It connects us to everything that has been and everything that will be in the grand story of cosmic evolution. You are not just in the universe, you are the universe, experiencing itself through the particular form of consciousness you call human. And this awareness, this cosmic connection, might be the most precious gift evolution has produced, a universe that knows itself through beings like you. Thank you for joining me on this journey through deep time and cosmic mystery. Remember to look up at the stars tonight and wonder, are we the first to ask these questions? Or are we the latest in a long line of conscious beings who have recognized their connection to the cosmos? Either way, you're part of something ancient and profound, the universe becoming aware of itself. And that perhaps is the greatest mystery of all.